All right, so right here is going to be the coding sequence that we were given. And I've gone ahead and grouped together the single nucleotide bases into groups of 3 to show our codons. Just makes it a little bit easier to notice what codon codes for an amino acid. Below is going to be our amino acid chain. And I like to view a sequence as a train and each of these codons as boxcars. So below is our sequence train and our amino acid boxcars. Go ahead and keep that analogy in mind as we work through these mutations. So first, I'd like to point out that in each mutation, you're going to see a single nucleotide base that is changed and represented in red, which means that we're going to be dealing with point mutations. So starting with mutation A, you're going to notice that we go from cytosine to thymine. Now, cytosine to thymine is what we're going to call a transition mutation. Looking at the amino acids, we go from asparagine to asparagine, which means it's going to be the same amino acid. In terms of our train, we're going to have the same boxcars and freight, so the train is going to have the same purpose. Since it's the same amino acid, this is going to be what we call a silent point mutation. Moving on to mutation B, we notice that we go from guanine to adenine. And guanine to adenine is what we're going to call a transition mutation. And looking at our amino acid, we go from tryptophan to a stop codon. So originally our sequence was 5 amino acids long, and now it's just 1 amino acid long, which means that this is going to code for a non-functional protein. And in terms of our train, the caboose came early, and it's going to be too short to be a functional train. It doesn't make sense. So this is what we're going to call a nonsense point mutation. And moving on to mutation C, we go from cytosine to adenine. Cytosine to adenine is going to be a transversion mutation. And looking at our amino acid, we go from alanine to aspartic acid. So there's going to be a change in our amino acid. And this is going to code for a different polypeptide sequence. In terms of our train, it's going to be a different boxcar with different freight, and the whole train's going to have a different purpose now. And this is what we refer to as a missense point mutation. All right, and moving on to mutation D, we're going to go ahead and notice that we go from guanine to cytosine. And guanine to cytosine is going to be a transversion mutation. And then we go from a stop codon to serine, which means that we're going to have a longer protein, and this is going to be known as a read-through mutation. So it's going to be longer than just 5 amino acids long.